Hello everyone, welcome back. This is Engineer Osam Wasapi. So in this video, we'll be tackling this question at hand. Now the question reads, determine the horizontal and the vertical components of the reaction at the pins A and C. Now looking at the structure in question, one thing you have to understand is that the members in the structure can be analyzed independently. What am I trying to say? So in this case, we can start by solving the first member, which is member BC. Let's start with this guy here. So if we say member B to C, the analysis shows us that we're having the member with B there and C. Now, C is a pin support, so we expect to have two reactions. C in the Y and C in the X. Now at B, be mindful that if I create a datum, something like that, we have member AB that is attached to member BC at an angle, which means that there should be some force within this member. And this force will be called force FBA. So we're saying from B going to A. So we have A there. We can create a random datum for A. We're not going to analyze A. We'll analyze member BC. I just need you to see the schematic of the problem. We have the 45 degrees there. According to the Z principle, we also have a 45 degrees right there. So we're saying that this is force BA, like that. Now, in order for us to draw a free body diagram that would be making sense for member BC, we need to understand that this rectangular distributed load can be condensed just to a point load. Now, how are we going to do that? All we have to do is to find the area. Now the area will be L by B, which is 15 times 6, and 15 times 6 will give us a value of 90 kilonewtons. And the centroid for a rectangular distributed load is always at L over 2, and L is 6 divided by 2. That gives us a 3 meters from B heading to C. So we have the point where I need to expect the point load of 90 kilonewtons, positioned at 3, which means this side will also have 3. But remember, the entire span is 6. With this done, let us now focus on the angular force FBA. Now remember, every time you have a force at an angle, always resolve your force into components. And that's basically statics. So to resolve this into its components, we're going to be having FBA cos 45 degrees in that direction. And we'll be having FBA sine 45 degrees in that direction. If you're having issues resolving the force into its components, don't worry, I've made a video. You can check it out on my channel. It's basically just how to resolve a force into its components. All right. So now let us sum up the forces by applying a global equilibrium check as usual. So sum of forces acting in the x-axis, taking this sense to be positive, should give us 0. So we know that the first that we can see here is Cx. So Cx is the first force acting in the x-axis. Then we also have this guy here, which is FBA. So FBA is in a negative sense, so we have minus FBA cos 45 degrees. And this is basically just equal to 0 because there's no other force acting in the x. So we say Cx is equal to positive FBA cos 45 degrees. And let us assume that this guy is our equation number 1. Then again, we can sum up the forces in the y-axis, taking the top part, boom, it's positive. So we have the first one, which is FBA sine 45 degrees. Then we have the 90 here. So the 90 is pointing downwards. You write downwards, negative 90. Then you have CY, which is positive CY. So you say plus CY, and that's equal to 0. Now we can write this as FBA sine 45 degrees plus CY being equal to 90. And we can call this bad boy equation number 2. Once we apply the equilibrium check for forces, we can now go to moments. So let us now sum up the moments at the point. Now looking at the free body diagram of member BC here, you'd find that there's a point, which is point B, having too many forces rather acting at it. So always take your moments at the point where you see a lot of forces so that they can all just explode and you will have nothing there. So if we take up the moments at point B, we say sum of all moments. So say sum of moments at point B, taking this sense to be positive, is equal to 0. All right. So the first turning effect will be from B. Remember, we're moving from B. The moment we take the moment at B, all these forces disappear. So imagine that there is nothing there. So the only turning effect to be done from B going towards C. So the first turning effect is from B at a dimension of 3 at the point load 90. So you have a turning effect in the negative sense, which is negative 3 times 90. Then again, remember, we are taking the moment at B. Don't make a mistake and change the moment that, no, I can walk on water or move the moment now at 90 and make a turning effect. That's being just too emotional. So you don't do that. So after that, you're going to have the next turning effect, which is going to have a dimension of 6. So we say plus 6 because it's in the positive sense, times CY, and this is equal to what? 0. Now, remember, 3 times 90 is going to give you 270. So you have negative 270 plus 6 CY being equal to 0. So you have 6 CY being equal to 270, like that. Solving for CY, divide by 6, divide by 6. You have CY being equal to a value of 45. So CY is 45 kilonewtons. Now that we have CY, we can go to equation number 2 and solve for FBA. So we have FBA sine 45 degrees plus CY being equal to 90. So FBA sine 45 degrees will now be equal to 90 minus the value of CY, which is 45. So you have FBA sine 45 degrees being equal to 90 minus 45 is 45. If we divide this by sine 45, even this side, sine 45, we'll be having FBA to be equal to 45 divided by sine 45. What will be our value? That will give us something like 63.64. Yeah, 63.64 kilonewtons. Just like that. All right, so now that we have the value of that, looking at the equations we have, we can also jump to equation number 1 to find the missing piece. And the missing piece is basically just Cx. So picking a portion, just to write this, I hope you don't get lost. You have Cx being equal to FBA cos 45. So Cx is equal to the value of FBA has been found to be 63.64. Now multiplying this by cos 45. So Cx is equal to, if we multiply this, we'll be having a value of 45 kilonewtons as well. Remember, we're supposed to calculate, or rather determine, the horizontal and the vertical, like that, of the reactions at the pins. We have the first pin A and the second one C. We have found all the reactions, which is in the horizontal and the vertical at C. We have the first CY, which is 45. The second X, which is here, is also 45. So now the next thing we're supposed to do is to analyze the pin independently. What am I trying to say? Let me erase this portion. Like I said, structures can be analyzed independently. So now let's analyze the pin. So pin A. Now remember, pin A has this force. This force, the vector here, protrudes to that end. So if I analyze the pin independently, create a datum of this kind, the vector, which is force FBA, protrudes to this end. And if we apply our basic math sense, we know that having that 45 here gives us a 45 literally here, which means that we can resolve this point A into its components. So we'll be having FBA cos 45 as well as in the Y, FBA sine 45. If we do a global equilibrium check just on the pin, we can sum up the forces in the X, taking distance to be positive, which should be equal to 0. Now A is a pin, so we should have reactions in the Y as well as in the what? In the X. So sum up the forces in the X axis. So we have AX minus FBA cos 45 is equal to 0. So we have AX being equal to FBA cos 45 degrees. So this means that AX is equal to FBA has been found to be 63.64 times cos 45. This gives us a value of 45 kilonewtons. If we apply the same sense for the y-axis, sum of forces in the y, taking distance to be positive, should be equal to 0. Remember, we're analyzing pin A alone. So pin A, sum of forces in the y, we have AY plus FBA sine 45 being equal to what? 0. So we have AY being equal to negative FBA sine 45. This gives us negative 63.64 times sine 45 degrees. And AY will give us a value of 45. Now remember, it's the magnitude that we're interested in. And the magnitude should always be positive. So if we do the math there, we have a negative sense, but a value of 45 kilonewtons, because our interest is basically the magnitude. All right. So that's basically how you go about solving this problem. Remember, you can always go back, check the steps bit by bit to understand how we have solved it in this problem. And remember, success is a product of your daily habits, not once in a lifetime transformation. So please, if you feel like forgetting, just try and go through this problem and solve it over and over again. All right, see you.